Astronomers have found clear evidence of what could be an Earth 2.0. This artist rendering shows the rocky planet identified as Proxima B orbiting the Proxima Centauri star.
The James Webb telescope recently made a discovery that totally shocked scientists. This find has got everyone asking, could there be life on other planets? The telescope was focusing on Proxima Centauri B, the closest star to Earth, when it spotted something strange. It was giving off unusually bright lights, almost like the glow of city lights. But what could be causing these lights on Proxima Centauri B? Could this be a sign that life exists beyond Earth? City lights in space. People have been wondering about life in space for ages, and scientists have been searching for any kind of proof for years. We've always been fascinated by the idea that we might not be alone planning on discovering city lights in space, especially not from a star that's so far away. This breakthrough is a huge deal because it's one of the first solid signs that life could exist elsewhere. For years, scientists have been waiting for something like this, a solid, tangible sign that life could be out there. And now, it seems like we're closer than ever to understanding whether we're alone in the universe or if there's something more out there. If it turns out that these lights are actually coming from an intelligent civilization, it would mean that societies in space could be way different from anything we've ever known. The thought of civilizations out there, just waiting for us to discover them, is both thrilling and mind-blowing. The idea that these city lights have been sitting there for who knows how long, waiting for the right technology to spot them, is almost unbelievable. NASA engineers, when they saw these lights from 7 trillion miles away, couldn't help but wonder just how long they've been shining. The fact that these lights seem to indicate some kind of civilization challenges everything scientists thought they knew about planets and life beyond Earth. If these lights are indeed from an advanced civilization, it opens up a whole new chapter in space exploration. Exploring Proxima B. It's well known that most rocky planets take in sunlight and release infrared energy, but Proxima Centauri B is different. Its infrared signature doesn't match what scientists expected from a planet orbiting its star, Proxima Centauri. That's where the James Webb Space Telescope came in. It was the perfect tool to study this strange planet. The telescope is equipped to capture infrared light, and that's exactly what it did. Proxima B's unique heat signature could reveal a lot about its atmosphere, and scientists are eager to dig into that mystery. Infrared bands are one of the telescope's specialties. And whether it could support life. This is important because Proxima B is in the habitable zone of its star, meaning it could potentially have conditions that allow for liquid water, a key ingredient for life. Scientists are particularly curious about whether this planet could sustain life, so they're hoping the infrared data from the telescope will help them figure that out. If Proxima B has an atmosphere that could support life, it would be a huge step forward in the search for life beyond Earth. The telescope's advanced infrared imaging could give us a clearer picture of whether there's a chance for humans or other life forms to one day visit, or even live, on this extrasolar world. Most space cameras struggle to pick up the faintest rays of light across the vastness of space, but this telescope can see even the tiniest glimmers. This makes it the perfect tool to check out reports of city lights on the nighttime side of Proxima B. Or the energy, but they also reflect light back into space, making the planet's surface even more intriguing to study. As Proxima B orbits around its star, it experiences day and night cycles, similar to Earth. During the day, the sunlight heats things up, and at night, things cool down. It's a basic cycle we know well, but what makes Proxima B so interesting is how its temperature changes in response to these cycles. This temperature variation is key for scientists because it can provide clues about the planet's atmosphere and how it responds to its star's energy. The telescope's ability to pick up infrared radiation from the planet will help scientists learn more about how Proxima B works, especially during its night phase when it's in the shadow of its star. Proxima Centauri B could have some extreme temperature swings between day and night, depending on whether it has an atmosphere. If this planet doesn't have one, one of the key tools they're using to learn more is the James Webb Space Telescope. It can quickly analyze the heat emissions coming from the planet, providing scientists with useful info about what Proxima B's atmosphere might be like. Thanks to its ability to detect infrared light, the telescope can pick up on details that other instruments might miss. This gives astronomers a clearer picture of the planet's climate and whether it could possibly support life. One thing that's interesting is that the telescope's orbit around Earth lines up nicely with Proxima B's orbital period. This means the telescope can fully observe Proxima B's day and night cycles, which last about 11.2 Earth days. That's a pretty good amount of time to gather data and make observations, especially since Proxima B is so far away. By watching how the planet's temperature changes over these 11.2-day periods, scientists can get a better sense of whether the planet's atmosphere is thick enough to atmosphere. By analyzing how the light changes as it moves through the atmosphere, they can figure out what gases are present. While the James Webb Space Telescope has made incredible strides, there's still more to be done in exploring distant worlds. Future of planet exploration. Even though the James Webb Space Telescope is amazing at describing the atmospheres of distant planets, it has its limitations. One of the biggest challenges is that it's not great at detecting bound oxygen, which is a key indicator of life. Oxygen in a planet's atmosphere could suggest the presence of living organisms, so it's something scientists are especially eager to find. But even with this limitation, the telescope can still search for other signs of life, like ozone. Ozone is another important marker because, like oxygen, it's often associated with biological processes on Earth. Despite these challenges, the James Webb Space Telescope is still one of the as it will help them understand the habitability of worlds that are much farther away than those the James Webb Space Telescope can currently study. Until the ELT comes online, the James Webb Space Telescope is still a crucial part of our exploration efforts. It may not be able to find everything, but it's still our best tool for uncovering the mysteries of faraway worlds. The data it gathers will continue to shape our understanding of how planets form, how they develop atmospheres, and whether they could eventually support life. The main goal for the next generation of telescopes is to reduce the bright light coming from a planet's host star. Right now, the intense light from the star makes it hard to see the faint light reflections from the planets themselves. So, to improve visibility, scientists are working on ways to block out that star's brightness. They plan to use special internal masks or big external satellites that act like shields, similar to how you might squint or science. Are we alone in the universe? However, there's still a lot of work to be done. One of the challenges is figuring out how to distinguish between gases that come from living organisms and gases that are produced by natural processes like volcanic activity. For example, volcanoes can release gases like carbon dioxide and methane, but these gases aren't necessarily a sign of life. So, scientists will need to be careful and develop methods to tell the difference between gases that might indicate biological activity and those that come from non-living sources. As we continue to make breakthroughs, the question of life beyond Earth is more pressing than ever. Life beyond Earth. As we keep exploring space, we're learning more about how the universe works and where we fit into it. Scientists have been searching for answers for decades, but even with all the advances in technology, they still haven't found solid proof of life beyond Earth, alien societies that might be out there. The idea of alien life has captured our imaginations for years, and the search continues with the hope that one day we'll find concrete evidence that we're not alone. One of the key organizations behind this search is the SETI Institute, founded in 1984 by two American scientists, Jill Tarter and Thomas Pearson. SETI stands for Search for Extraterrestrial Intelligence, and their mission is to search the universe for signs of alien life, specifically looking for radio messages coming from space. Radio waves are interesting because they can travel across vast distances without getting lost or absorbed like other types of radiation. This makes them ideal for long-distance communication, and scientists believe that if intelligent life forms exist, they might use radio signals to communicate. Despite SETI's efforts over the past 30 years, they haven't yet found any solid proof of alien signals,